uh, so we have given ZL is equal to 100 plus J50. Z naught is given as 50 ohm, right? And we wish to find out YL, Zin, Yn, and the reflection coefficient values. So first step for the Smith chart is normalization. So ZL bar is given by ZL upon Z naught, and it will be right. Now we'll go back and have the Smith chart. So here I have the Smith chart. So the second step is to find before going into that, I'll mark these are the constant resistance circle lines, and these the lines or the arc which are above the horizontal line represent the inductive behavior, and below the line represent the capacitive behavior. And as our ZL bar is 2 plus J1, so we need to mark 2 plus J1 in the Smith chart. So how to do that? So first of all, I'll find 2 ohm line and need to find the J1. So since it is plus J1, so will be going above the horizontal line, and if you see this is 1 ohm line, so 1 ohm arc, so we'll go back, and this one will be our intersection point. Next is to draw the line. So we'll put a scale. As you can see, I have drawn a line passing through the center of the Smith chart and the intersection point. Now the next step is to draw a circle. The radius of the circle must be equal to this quantity. This will be the radius of the circle. So at the center of the Smith chart, I will draw a circle. Now I have drawn the circle. Now to find the uh, angle of the reflection coefficient, we need to go on angle of reflection coefficient, and if you go through, it is something around 26.5. So the angle is 26.5 degrees. Okay. Next step is to draw a line, vertical line, at the point of intersection of the circle and horizontal axis at this end. So we'll draw it. So now we have drawn the vertical straight line, and if you see, it cuts reflection coefficient at something around 0.45. So let me mention 0.45. So therefore we mark the reflection coefficient as 0.45 with an angle of 26.5 degree. So this is our reflection coefficient. So the amplitude is 0.45 and the angle is 26.5. Right. Now this is A, B, C and D. So we have find out part D first. Next is to find A, Y, L. Okay. So to do that, now we need to focus on this side of the intersection of circle and the line. So just focus over there. So it has constant resistance circle. Cut the constant resistance circle around 0.4. So I'll mark it that YL is equal to 0.4, sorry, YL bar 0.4 minus the C, 0.4 minus, I'll say it is 0.2, let's say 0.21 minus J 0.21, right? So the YL will become YL bar divided by Z naught. Okay, so it will become 0.08, oh sorry, 0.008 minus J 0.0042. Okay, so this will be the value of YL. For our next part, we have a transmission line terminated with ZL and we have a generator, and the L is equal to 0.15 lambda, right? So H, and we need to find input impedance at this point. So as we are moving towards the generator, so in the Smith chart we'll go by the clockwise direction. Now we need to know how much clockwise uh, direction you need to go. So the theta value, theta change, I'll write change. This is given by 740 into, so I'll write the theta change is equal to 720 into 0.15 because the length is 0.15 lambda, so it will become 108 degrees. So in the Smith chart we need to go 108 degree clockwise, right? So if you move on this part of the Smith chart, okay, you move this part of the Smith chart, you can see here the angle is 0 degree and then start increasing to 20, 30 and again. So to go to 108 degrees, first we need to come here at, so it will count 26.5. So and again in the lower half we need to go 108 minus 26.5. So it will be 108 minus 26.5 and it will become 81.5. So now we will find the 81.5 line, 81.5 angle. So if you see over here we need to mark 81.5. So what I have done, I have marked 81.5 line, and next I need to draw a straight line passing through the center of the Smith chart and this point. So now I have drawn the straight line and now we need to find this point. So I can say 0.75, yes, 0.75, and J value is around 0.83. So this is 0.83, this is 0.75. So I mark it Z in bar is equal to 0.75 minus J 0.83. And why I put the minus? Because we are the below the horizontal line, and then Z in will become Z in bar into 50, and that will be around, so this will become 37.5 minus 41.5 J. So the Z in value is become this much, 37.5 minus 41.5 J. In the next step we need to find the Y in value. So similar to the finding the YL value, we now go and see where at the opposite end it cuts the circle, right? So suppose this is the circle, and if we make it we point it out, so we need to find out those values. So now we see it cut it around 0.61. Okay, I'll say it 0.61 and 0.65, 0.66, I'll say 0.66. So the constant resistance circle is 0.6661 and the reactance value is 0.66. So what I'll do, I'll write over here YL bar is equal to 0.61 plus J 0.66. Why I have written the plus? Because it is above the horizontal axis, and this is not Y, sorry, Y in. So Y in is equal to Y in cap, sorry, bar divided by Z naught, and it will become 0. So it will become the Y in value will become 0.012 plus J. The this circle, whole circle, is called constant SWR circle. So the amplitude of the reflection coefficient can also be defined with the constant SWR circle. So suppose it cut it around 2.6 over here. So SWR is 2.6. So what I'll do, I'll put a formula over there. So SWR is equal to 1 plus modulus of rho, that is deflection coefficient, 1 minus modulus of rho. So 2.6 is equal to 1 plus so from here you can find the modulus of rho, and it will be around 0.45. Okay, thank you.